Ladies and gentlemen, hello and welcome to ROG Pulse, the podcast where we talk about all things technology here at the Republic of Gamers. My name is Solid Jake and I'm joined here by my good friend Sasha. Happy New Year.
Hey, happy 2021, Jake.
New Year, doesn't seem like much has changed. Not yet, but it will, What did you do over the holiday break? Anything special?
Well, special in the sense of working a lot, yep.
But
Because, CS is coming up, so not really much time for anything else these days.
that is true. CES is just a week away, and tonight we are actually doing another CES preview, going over basically the laptop cooling technologies and how we're improving that in our devices moving forward. We're going to give you guys a bit of a teaser as to kind of some of the updates and upgrades we have made to everything from the entire device cooling to CPU cooling. A lot of different things to talk about there. And of course, next week we are going to have an insane amount of news with several streams. I can tell you right now that I'll be doing a stream on Monday, showing off something brand new. And then on Tuesday, there's going to be a ton of new stuff. So there's going to be a lot of content coming, but today's kind of our short little warm up, I guess. We're preparing for it. But Sasha, before we jump into the conversation about our laptop cooling, have you been playing Cyberpunk? It's the hot topic, even now, months, not months, but months and years of waiting, and now a few weeks with the game out. Obviously, a lot of controversy. Have you played it at all?
No, I haven't. I haven't had a chance to play it at all.
None.
But I watched some gameplay footage. I watched a lot of gameplay footage actually. Well, not that much either. But yeah, I think it's pretty entertaining. It's kind of like when Red Dead Redemption 2 came out. I was watching that for weeks, like all the weird bloopers and all the weird stuff that happens, all the glitches. That was hilarious. Like Red Dead Redemption 2 was really very entertaining for that. And now we got the Cyberpunk 2077 to keep us entertained with all the interesting palm trees melting and like all the really weird stuff that's happening, all the T-posing and stuff. And yeah, the latest I saw was I've been very busy, and if I do want to unwind and I have like 5 minutes or something, I usually watch some funny gameplay clips on YouTube. That's
Okay.
kind of like my go-to. And yeah, Cyberpunk 2077. There's like a third-person mod now.
I watched the
That's
video.
it's pretty janky. Yeah, I told you about it, right? It is really janky, and it's really fun though. Like it's really, especially when you're aiming down sight, it just looks hilarious. Looks like you're threatening yourself, like you're robbing yourself with a gun in your neck and everything. Yeah.
Yeah, the first person is very awkward when you ADS. But guys, we are live. This is not pre-recorded. We do this live, so yes, we will interact with chat accordingly and take some
Oh
questions
yeah, how's chat?
throughout the show.
Happy
Yeah.
New Year, chat. How have you been? What's new with you guys? Share your dankest memes with us.
You need high end to run it. I'm lucky enough to have a 3070, and I've played a bit of Cyberpunk on the
Mm.
3070, and it's phenomenal. It really is
It does look awesome. I
gorgeous.
mean,
Just the
you
ray
have to say,
tracing.
yeah.
Yeah, it is really nice. So all right, Sasha.
I'm,
Well, let's jump into the conversation here because we're talking about our 2021 laptop cooling updates. And overall, I think we call it the intelligent cooling philosophy, where we're always looking to make sure that we can maximize the cooling for performance, we can minimize the noise, and make sure that you have full control of the thermals. But what does that exactly entail?
yeah, sorry, I'm a little bit offset by our new setup here, and I'm not used to having a microphone in front of me all the time. It's weird. It feels like, somebody's invading my private personal space. It's weird having it so close to my
You'll get
face all the
used to it.
time. Yeah. And I mean, I hope chat also appreciates the sound quality. Hopefully it does sound a lot better. Yeah, so intelligent cooling is always a trade-off because there's a lot of different things you need to take into consideration. And it's actually interesting because when you ask different people, what does good cooling mean, or what's a powerful cooling system, everybody has a slightly different notion of what does that actually mean. So if you ask some people what is good cooling, they'll tell you, oh, it's super quiet, I can't hear it. Other people will tell you good cooling means low CPU and GPU temperatures, and either noise is not that important or they even want it to be loud. There are some people who say good cooling means, I can hear the fans and they're pushing tons of air through the system. That's good cooling. Even under the heaviest load, there's tons of air going through the system. So others consider good cooling. I can touch the laptop under super heavy loading and it's cool to the touch. I can't even feel that, there's something going on in the system. So there's a lot of different nuances to this. And for us, good cooling is something different as well. We have to take into consideration all the components inside of the system. So the VRM components that take the 20 volts from your laptop adapter and then break it down into 1 point something volt to feed to the CPU and the GPU and the memory and so on. Those components that transfer the power, they also get hot. We need to make sure we cool them. Then we have SSDs, we have other components on the motherboard chipset and so on. We have to cool all of that, memory as well.
Right.
So yeah, you have to always find a good balance for that, and performance is directly impacted as well. Like we mentioned several times in the past, especially in the laptop, when you're so constrained with space, it's very different from a desktop PC. Every little bit of extra cooling performance you can get means you can boost up the CPU and the GPU and get extra performance out of the system. So all of this you have to balance. You can either go for maximum performance, you don't care about component temperatures, surface temperatures, or fan noise, or you can find a different kind of balance. You make it super quiet, but then you have to limit the performance a lot. And that's kind of where the name intelligent cooling comes in, because we try to do it intelligently, and we believe we are doing it pretty intelligently. So that's why we're calling it intelligent cooling overall. And a big part of that is also because we have different operating modes. That's to cater to all those different audiences that have different preferences. In the past, we only had one single operating mode. So our laptops would always that's the fan setting that we use for this temperature. And that's the temperature target for the CPU and the GPU. And that's the performance we get out of it. And we would constantly get requests and complaints from people who were on either side of the spectrum, saying that, they want the temperatures to be lower, they want a system to be quieter, they want more performance, they want the fans to spin higher and be louder. So to kind of cater to that different audience, we created different operating modes. So we have a turbo mode that's all about performance, and we try to get, the best performance out of the system possible. And it comes at a cost. You do get higher temperatures and higher fan noise, but that's kind of like the performance mode. There's a lot of people who want something like that.
And that's been around for quite a while, right?
Yeah, that was the first mode that we phased into our gaming laptops around 4 years ago. Around 1 year after I joined.
And it was probably on the motherboards even before then, because I have an older Asus motherboard that had that as well, I believe. So
yeah, it's kind of interesting, because on our older gaming laptops, we did have different operating modes already, like way back. So, but at some point in time, it went away. I'm not entirely sure why.
So there's a good question from chat. These different operating modes, what devices is this available on? Is it everything, or is it only some devices?
All our gaming laptops have it.
Nice.
Yeah. And so originally we had, the balance mode. Then we created the turbo mode for people who want, more performance. And then we created a silent mode, where we essentially try to find the best balance between performance and still making it super quiet. And that's very interesting, because around the same time that we created our silent mode is when we were working together with NVIDIA on the original Zephyrus GX501, and when NVIDIA was developing Max-Q, which is a very similar idea. The original idea for Max-Q was just that, trying to make it as quiet as possible and still have really good performance. The original noise target for Max-Q was 40 decibels or less. So yeah, that was pretty interesting. So we have silent mode, balance mode. We call it performance mode now. It was originally called balance mode. So silent, performance, and turbo. Those are the three main modes. And then on top of that, we have our manual mode, where we let users customize the system settings, and you can actually create your own fan curve for the CPU and the GPU. So you can define that at what CPU temperature do I want the CPU fan to spin at what speed, and at what GPU temperature do I want the GPU fan to spin at what speed. So a lot of customization there. You can also overclock some of the models, the CPU and the GPU, depending on the model. You can overclock both CPU and GPU, or maybe only the GPU, or you can't overclock at all. That depends on the model. But there's always a manual mode to let you fine tune the acoustics and the fan. So yeah, we have those different modes to cater to different people. And then a big drive of the original intelligent cooling was we just phased in scenario profiles, which is basically taking the whole thing to the next level. With scenario profiles, you can have app-specific automation for the operating modes. So I think I mentioned that to you last time. You can, for example, when you're watching Netflix, you don't need your system to run at full performance, right? So
Right.
you can create a scenario profile that as soon as Netflix is the main app, the focus app in Windows on your desktop, as soon as that's the case, then it switches automatically to silent mode.
That's
And
really
then it
cool.
limits the system performance, but it's super quiet. Yeah, because for binge watching, you don't need the CPU to
Oh, yeah,
turbo to the
absolutely
highest
not.
clocks.
Yeah,
And
and sometimes you're saving power on that at that point. You're reducing
yeah, yeah.
noise. It's
Mm,
benefits in multiple ways. So that's
hmm
really cool
And you can
technology. Now, how do you set that up? How do you get to that interface to be able to choose those options?
So you can use keyboard shortcuts for that. We have keyboard shortcuts with the FN key to just toggle through the different operating modes, and
Oh,
you just
nice.
switch between the different modes. And then there's a little OSD, like on-screen display. We call it OSD. It's a small icon that pops up on the bottom of your display, and it tells you right now it's in performance mode or silent mode. You probably noticed that on your Zephyrus Duo, when you boot it up, it usually like tells you, okay, right now, what mode is it in?
And actually, I remember now that you bring that up, in Armory Crate, you can choose all those things as well.
Yeah,
The Zephyrus Duo is a bit special
yeah, an
because
Army crate.
you have the
Yeah.
secondary display with the
Mm.
full performance indicators where you can look at all the different levels and how it's being used and where the resources are being allocated, which is pretty neat
Yeah,
in that
the
device
resource
specifically.
monitor.
Yeah,
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 yeah.
it's really nice.
We have that on Armory Crate for all the models, but then on the Zephyrus Duo, like you said, you can put it on the
It's a
ScreenPad
bit
Plus, and you
special,
can
yeah.
see all of it. Yeah, yeah. So you can basically use the ScreenPad Plus to monitor all the system stats. It's really really useful for the ScreenPad Plus. Yeah.
I'm really
So
obsessed with
yeah,
that device. Uh, cool.
glad you like it.
Yeah. Okay, cool. So there's a lot of different components when it comes to managing this and choosing your profile and creating that perfect user setting. What else goes into leveling up our cooling when we're looking forward?
When we're looking for what?
Forward, when we're like in 2021,
Oh,
we're
okay.
stepping it up. What are some other things we're doing to raise the bar in our cooling performance?
So we are constantly improving our fans, for example, and we were the first to bring LCP fans, liquid crystal polymer, to gaming laptops. LCP is something I think Noctua uses that as well. It's very it's a high-end, high-performance polymer. So polymer essentially is plastic, but there's different types of
It
plastic,
sounds
and
way
they're
cooler when you call it liquid crystal. Like it just does.
exactly. Yeah. So polymer is a very fancy name, right? Like that's the scientific chemical name. But essentially, it is plastic. But just to be clear, there's very different types of plastic. You have ABS, you have LCP, you have POM, you have ALS. So especially people who are into 3D printing, as soon as you start going into 3D printing, you become aware of all the different plastic versions and polymer versions there are and what the pros and cons are. So they're very different behavior and material characteristics. And LCP has a very cool characteristic. It's polymers are essentially long chain molecules, and liquid crystal polymer is special in that when it cools down, so you inject it into the mold at very high pressure and temperature to create the fan, and then as it cools down, all those long chain molecules connect with each other, and they kind of like form a crystal lattice, and they interlink with each other, and they connect at several points along those long chains, and that makes them super strong. So the overall structure becomes really rigid and strong. That then means you can make the material thinner, and that's great for fans. So the thinner you can make the fan blades, the more fan blades you can have on the fan, and then with each spin of the fan, each rotation, you can push more air. So yeah, we're bringing LCP improvements to our 2021 laptops that are coming up. And yeah, we have a newer, improved fan design that helps to reduce the noise and increase the airflow as well.
Um, What about arc flow fans? I know that's something we've talked about. Do we have anything
Yeah,
like that we
so
can show off?
yeah, I got one here. So the Arcflow fans are using the latest LCP. So here you can see the fan. This is the fan chamber. Sorry, I think my hands are casting shadow. Yeah, that's better. So this one is with the capsule on for the fan chamber, and for this one I removed it. And there inside you can see the new Arcflow fan. So this one, let me hold it closer to the camera. This one is with LCP,
Come
the
on,
latest
focus.
LCP.
There, we can kind of see it. It's focusing in and out. Sometimes this camera is a
It's a little bit
gem.
too
And
close,
other time,
maybe.
yeah, there we go. There we go. That's
There we
better.
go. I think it was a little bit too close. Yeah, so there you can see that's 0.1 millimeter blade thickness in the center right there. So those are the arc flow fans. And you can see that the fan blade thickness, so these are the latest LCP, the fan blade thickness varies along the fan blade. So in the center, it's super slim, so it
Mm-hmm.
can take in more air and the air resistance is lower. And then as you get closer to the outside of the fan blades, you can see that they're getting thicker. I don't know how well you can see it here, but they're getting thicker. And the reason for that is we want to keep the air pressure constant as the air travels from the center of the fan to the outer edge of the fan blade. And that makes sure that there's no fluctuations or turbulences. That helps with acoustics and airflow. And arc flow, so why do we call them arc flow? Let me see if we can focus again.
A little bit off. There we go. Give it a sec.
Just a
Pull it
second.
back just a
Yeah.
little bit, maybe.
So on the
There we
outer
go.
edge, there we go. On the outer edge of the fence, can you see it at this angle?
Kinda. I can. There's definitely
Yeah,
like a flow, like the up and down, the like a wave.
yeah. So when I spin the
There, you can
fan,
see it
you
better when
can
you spin it.
see there's like a pattern, there's like a wave going up and down and up and down, right?
Yep.
So this is what we call the arc flow fans. These are the latest fans. Very cool biometric nature-inspired fan blade design. And the gist of it is, so you would think that the best way to move air from one point to another is you just push it in a straight path at a constant speed without any interference. But in reality, what happens is you constantly have some small disturbances in the airflow build up. You have those random turbulences constantly appearing and then disappearing. And those turbulences hurt the airflow and they create unwanted acoustics as well. And with this wave pattern, what happens is when the fan spins, we actually generate a wave coming out of the fan itself towards the heatsink. So the air pressure and the air direction is constantly changing slightly at a rhythmic pattern. And it seems kind of counterintuitive. Like, why would that be better? Why would you constantly mess with the airflow? Just leave it alone. Just, let it go straight down the path. But if you constantly mess with the airflow slightly, you're actually breaking up all those small turbulences that form. So
Huh.
before those turbulences can become too strong and then really cause issues with the airflow, you're kind of like pushing them around and shifting them away and interrupting them. So that way, overall, net, you get higher airflow and better acoustics. Pretty impressive design.
It is really cool. One of the questions we have in chat is actually with really small blades that are so fine like that, wouldn't that
Mm-hmm.
cause dust to be an issue?
How so? I can't really tell why dust specifically with the thin blades would be an issue, but it's not really a problem for our thermal modules. So maybe that was a hint towards maybe somebody knows about our dust release system. So yeah, we still have our dust release system. We have that on all our gaming laptops. We've had that for a few years. And the idea behind that is what happens with gaming laptops or any laptop really as they age is dust slowly builds up in the heatsink.
Yep.
It gets stuck on the metal fins and it gets more and more and more and more. And over the time, over the years, depending on how dusty your environment is and if you have somebody in your household who's smoking, that actually makes dust buildup much worse because you have those tiny sticky particles that just clump everything together. So you end up with a lot of dust in the heatsink that blocks the airflow through the heatsink. And then as a result, first the laptop gets louder because the fan has to spin harder to push the air through.
Right.
And then over time, even with the fan spinning at higher fan speed, it still gets hotter and hotter. So first it gets louder and louder and louder over time, even when it's just sitting there not really doing anything. And then eventually it gets to the point that even though the fan is constantly spinning at a high speed, you're still getting really high surface temperatures and component temperatures and poor performance. So to avoid that from happening, we created a dust release channel that's similar to a certain vacuum cleaner where the air is spinning in a circle inside the vacuum cleaner.
Huh.
And we're able to, because dust is heavier than air. So if you spin something in a chamber in a circle, the dust particles are heavy and they get pushed out to the outer edge and they're squeezed against the outer edge. And then all we have to do is just add a little channel here. Let me see if I can get the camera to focus on that. So we add a little channel, and in that channel, this is where oh, wow, it's reflecting. Oh, yeah,
There we
that's
go.
better.
Yeah, we can see
So
the channel.
here's a little channel that the air then gets the dust then gets pushed through here. So the dust is heavier, so it gets pushed to the outer edge of the fan chamber, and it travels along the fan chamber here, and then gets pushed through this channel, and this goes straight out of the laptop without going through the heatsink. So that way, most of the dust, almost all the dust, goes straight out of the laptop and doesn't actually touch the heatsink fins. So there's no chance that it gets stuck in the heatsink fins directly.
So this is basically a self-cleaning technology that's going to keep the laptop running as well as it can for as long as possible for years and years and years.
Yeah, exactly. And you'll see a very big difference after, depending on the environment. So it's hard to quantify
Sure.
how dusty it is where you live, and how
If you're
dusty your household
using
is.
your laptop next to like a wood bench where you're using, sawing things and there's sawdust in the air, you're
Oh,
probably
yeah,
going to
yeah,
have
yeah.
sawdust in your PC. That's just like
Yeah.
common sense. But if you're using it in a controlled environment, you'll be fine.
Yeah, humidity plays into it as well. Smoking or even vaping, or like if you have a chimney, like if you have a camp, if you have like a
You
fireplace
say
in your home.
vaping will affect your PC? That's
Yeah,
huh.
yeah, yeah, yeah.
Never.
Because you have those tiny particles,
I
oil
it makes sense.
particles in
Yeah,
the
yeah.
air. Yeah. And yeah, so it's hard to quantify, but essentially, yeah, it does extend the lifetime or the performance of the laptop acoustically and when it comes to like system performance over the years. So there's a really nice improvement with that.
Sasha, when are we making ROG air purifiers?
Yeah, that's interesting. We actually had somebody propose that.
Really?
Can we use that? Yeah, yeah. Like when we were explaining the self-cleaning fan design, can we add something to it, like an EPA filter, an HEPA filter,
Yeah.
or something like that? And yeah, we could, but the amount of air that goes through the laptop isn't actually that high. So
Right.
to clean the air in your room would probably take a pretty long time, even if the fans are running at full speed. And then also like you have to change the filter, and it hurts the airflow. And yeah, so that's one thing I wanted to mention as well. How much air you're pushing through the laptop makes a huge difference as well. So if you're playing games constantly, that means the fans are running at a higher speed, so there's way more air going through the laptop. So of course, more dust is going to build up as well. If your laptop is mostly in idle mode, then you're not gonna have that much dust build up. So yeah, really depends on how you're using the system. And what's new for 2021 models is you can see on this one, the channel that I pointed out is really short. So again, let me hold it up into the camera. You can see that this channel is really short. It's only from here to here, right? On the older models, the fan chamber had a much longer channel that started somewhere around here. And we found out that we can make the channel much shorter and only have it down here and still get like 80-90% of the same effect of pushing out the dust particles. And it's better to have it shorter because since there is no channel over here, we can make the fan diameter slightly bigger. So bigger fan obviously means better airflow. So that way we can boost the airflow and still have the benefits of the self-cleaning system pushing out the dust.
Very cool. That's some interesting stuff. Nice upgrades coming across the board with the fans. Chat does seem disappointed that they can't buy a dedicated RGB air purifier yet, but maybe someday we'll get that on the. I mean, I'm not even talking about in the laptop. I'm talking about its own separate device because make it happen.
Yeah, I mean, maybe we'll have something like that announced in 4 months from now,
What?
in
Well,
April.
okay. He's telling us there's a hope. I mean, I don't know if he's memeing because I've heard nothing, but we're
No, it
gonna.
was a reference to April 1st. I
Oh,
mean,
oh God.
that was
Okay.
fine.
He
Yeah.
was memeing.
Sorry, sorry.
Oh,
Whoosh.
yeah, right over my head. I'm not clever enough for that. Okay. Well, ArcFlow fans, really cool stuff. We talked about the improved self-cleaning that's built into these devices. Um, you know, I know one thing that we're always looking at is the volume and 0 dB technology.
Hmm.
Let's talk about that.
Yeah, that's pretty cool. So, we have our silent mode that is really quiet. It's only 35 decibels. I forgot to mention that. So the different operating modes. The turbo mode is around 50 decibels usually,
Hmm.
and the standard performance mode is around 45, and then silent mode is only 35 decibels. So yeah, 35 decibels is really quiet. You can still hear the fan if you're in a super quiet room, but it's really quiet. That's generally the noise level that people consider to be, that system is quiet, the laptop is quiet, the PC is quiet. It's around 30 decibels, 35 decibels. And yeah, so in silent mode, it's 35 decibels, but less is always better. So when you're not really using the system much, when it's in idle and the temperatures are low, we are now able to completely stop the fans from spinning. So in 2021, all our new models are going to have 0 dB technology, which means when they're in idle and the CPU and the GPU temperature is below a certain threshold, around, if it's under 50 or 60 degrees, it depends on the model, the fan stops spinning entirely. So you get like no fan noise at all, zero fan noise.
That's nice because before, you're right, the fans never stop. Can't stop, won't stop.
Hmm.
But now
Yeah,
we have the technology.
they can. You can tell them to shut up. Yeah.
Cool. All right, that's a neat little update. And guys, you're asking about CES next week. We will have lots of announcements for CES. Don't worry. But you gotta wait till next week. Okay. So
For the 0 dB fans, I just want to add, so
yeah.
it's, if the fan stops spinning under, let's say, 50 or 60 degrees, so people might think, oh, okay, but that only happens in idle, and maybe even in idle, the fans are going to spin up and then they stop and then they spin up again. So we tested this on a couple of laptops, and with a normal ambient temperature of around 22 degrees, we actually had several scenarios where we're using the laptop just normally as you would use your laptop on a day-to-day basis without playing games, just, browsing emails, PowerPoint presentations, browsing the web, and that kind of stuff. And the fans never spun up at all for the whole day. So it really depends on the model and what you're doing. But yeah, like this isn't just like, oh, in idle mode, if you do nothing, then the fans stop maybe half of the time or most of the time. No, it's like even when you use the laptop, the fans stop in idle. That's really cool.
Yeah, that is gonna be really nice. Nice quality of life change there because
Hmm.
frankly, laptops are always humming away. Okay. Another thing that I know that we've been working on is, we've actually done a few shows on this. Maybe even, was it our first show ever on Pulse where we talked about liquid metal? Was that our first show?
Huh.
I can't
I can't
remember. Yeah,
remember.
yeah, yeah. It was
Yeah,
it
I
was
can't
definitely one
remember.
of the first shows. We
It
talked
was one
about
of the first. Yeah.
we
Yeah, I
talked about
remember it was Ryan and I. Yep.
Yep,
Yep.
yep. So we went in and just really dove into the process of liquid metal, how we've developed this whole process where we have a fully automated system to apply the liquid metal, properly. And liquid metal is really difficult to work with because
Oh
one
yeah.
one drop on the motherboard, and especially with the laptop, the whole system's fried. Right? You
I
get it in the wrong
remember
spot.
having to scoop that up from the desk. Yeah, I remember we pressed on the little thing a little bit, and all the liquid metal came out and was on the table instead of the CPU that we wanted to show it on. And then I remember after the show, I think I spent like 10 minutes trying to scoop that back up
Just squeegee it
into
up to
the
preserve it.
applicator.
Yeah, yeah.
Yeah, yeah, yeah. Because we had to, like, we borrowed it. We literally borrowed it from our thermal engineers. And they're like, I need this spec and I need all of the liquid metal to be in there. So, yep, yeah, I remember. It's definitely not easy to apply.
Well, so with liquid metal, what are we doing new with it for our new laptops?
So in 2021, we're bringing liquid metal to all ROG Strix and all ROG Zephyrus models. So regardless
Everything.
of everything, yes, regardless of whether it's an Intel CPU or AMD CPU, we're bringing it to all the new models.
Now, have we ever put it on an AMD CPU?
Well, yeah, we tried, and the special thing about that, or why it's more difficult to do, is because for some CPUs, the CPU package is relatively bare. So you just have the package and then the silicon die in the center, and that's the best case scenario. And on other CPUs, you have a lot of SMD capacitors very close to the CPU package. You have that on GPUs as well. You have all those small squares, those blocks close to the GPU silicon die. Those are capacitors. So they help to even out the voltage fluctuation as the chip is under heavy load.
Right.
But obviously, those are sensitive to being short circuited. So you need to make sure that you isolate them. And it sounds straightforward enough if you think about it. Like I know that in the enthusiast space, the general thing, I mean, I've been doing that as well for years, is you just use nail polish essentially, and you just cover it. Or you can use any kind of paint really that doesn't damage the PCB, and you just cover all those extra components. That's done to prevent isolation. When you go sub-zero, when you're overclocking with fancy cooling, really exotic cooling, but also when you want to isolate it from electric connectivity like liquid metal, you just apply a coating. But that's for enthusiasts. When you have to do this as a manufacturer and you have to mass produce it, that's a whole other story. You have to guarantee that it works for several years, and
Right.
you have to do a lot of testing. So that took a while, but yeah, we managed to make it work now. And another thing is, so we have to cover it up with some material. That material has to go through a crazy amount of heat cycles. So if you think about it, that's very close to the silicon die. That gets pretty hot, and it gets very hot and then cold and hot and cold. So you have all these cycles, and that material, everything when it gets hot and cold, it expands and shrinks, especially metal, right? And you need to make sure that material expands and shrinks at the same rate as the capacitors and the PCB. So otherwise, what happens is they start to there's a gap forming between them, and then the liquid metal can seep in there. So yeah, we want to make sure we get it right. We want to make sure this is something that lasts for years, and that's why it took some extra time to get it to work with CPUs that have a lot of SMD capacitors close to the silicon die, like AMD CPUs.
Makes a lot of sense, but that's exciting to hear that it is coming to all AMD CPUs on our laptops. One of the questions in chat is, do you think we'll ever see liquid metal on GPUs in the future for
Yeah,
desktops
it's
or
definitely
laptops alike?
it's definitely possible. I mean, people are doing. I did that on my graphics card at home.
Really?
And yeah. And again, there's like some people saying, oh, but it degrades over time. And again, it's good to bring that up, I guess. This degradation over time, that the liquid metal disappears or evaporates, that's what some people are saying. That's not really what happens. So what happens is liquid metal is a mix, an alloy of different metals that are liquid at room temperature, and those metals are somewhat reactive to very reactive to aluminum, and they're even somewhat reactive to copper. So what happens is, on your heatsink, if you apply that liquid metal, over time people think that it dissipates or just leaks out or disappears. What really happens is that those liquid metals slowly seep into the copper or into the aluminum. So they kind of eat tiny holes into it, and then it becomes like a sponge, and the liquid metal seeps into the heatsink itself.
That
That's why people think it's disappearing.
doesn't sound good. I mean, it's probably
Yeah,
not the worst, but
it's not the worst, but obviously it's not good, right? So that's another thing where we work very closely with Thermal Grizzly and Der Bauer, who's an extreme overclocker who's working with Thermal Grizzly, to make sure that that doesn't happen for our laptops. So the way to stop that is you add a nickel plating to the heatsink, the cold plate that touches the CPU or GPU. You add a nickel plating there, and then that way it doesn't react with nickel. So then you don't have to worry about that at all. And yeah, we're doing that on our heat sinks as well. And so coming back to, will we see it on GPUs, on desktops? I think on desktops it makes a lot of sense, but I can't speak for our VGA team, because especially now with GPUs going to crazy high wattages like 350, 400 watts, getting to really high power densities, and the chips getting smaller. I mean, they're still huge, but they're smaller than they were in the past, even the GPUs. So yeah, I think it would make sense. And for laptops, the power density is not that high. So the reason why we started with CPUs is because, all right, in a laptop, CPU you're usually around 45 watts. GPU usually around 100 watts to 150 watts, something like that. So you would think GPU, higher power, more heat. So that's where you should use liquid metal. That's where you get the biggest improvement. But GPUs, first of all, the chip is much bigger, so the power density is lower. And second of all, on a GPU, you have thousands of CUDA cores. So those tiny parts of the GPU, and each of them does one bit of work. You have thousands of them. It's a highly parallel structure. That means the heat is spread out very evenly over the GPU as well. On a CPU, you have 4 cores or 6 cores or 8 cores, on desktop even more. But those cores, each of those cores has one hotspot where most of the work is happening.
Okay.
That's the part of the CPU core where no matter what happens, this part of the CPU is always active and doing something. So that's the hottest part of the CPU. So those hotspots are much more serious. Oh, that's a serious thing on CPUs. So that's why on CPUs, liquid metal actually has the biggest improvement. So we're seeing around, on average, a 10-degree temperature drop going to liquid metal, depending on the load you have on the system and depending on which laptop, and up to 16 degrees. So far, in one scenario, we saw on one of our laptops going to liquid metal 16 degrees. And I'm talking about the upcoming models here. So that's really what's coming to market.
Cool. I think we have one other thing to demonstrate here, right?
Mm-hmm.
What do we got? What do you got for us? I see it there.
Well, we got a thermal module, and this is for an upcoming laptop that we're going to announce in, let me check the
like
time.
four or 5 days.
Yeah, it's a couple of days. We're going to announce this at CES, and you can see it's extremely compact. And yeah, as gaming laptops, the overall trend for laptops, all electronics really, is to get smaller and more compact, right? And we want it to be really lightweight. Yeah, so we're taking things to the next level, taking things to a point where it's even lighter and even more compact. And that's very challenging for cooling. Because, like I said earlier, for a laptop, you have everything in this tiny, compact space, and you still want really good performance. So you need a lot of cooling performance, and that's very challenging. A lot of people, I think, generally, very few people are aware that what we call the X dimension, which is the length of the laptop, the width of the laptop, that's crucial for cooling the laptop. And the reason for that is because you want as large of a surface area on the heatsink as possible. So you want a lot of those metal heatsink fins. So you can see right here, we have like heatsink fins over here. Why don't we make it wider? Well, first of all, if you want to make it wider, you would need bigger fans. That means the thermal module over takes a really high percentage of the overall laptop. And second of all, you can see you have the GPU and the CPU over here.
Yep.
You want the CPU and the GPU to be as close as possible to the rear end of the laptop. So this is where the air gets exhausted towards the rear side of the laptop. And then your keyboard would be over here. If you push the CPU and the GPU further towards the center or the front of the laptop, you'll have it right under the keyboard or the palm rest. That's obviously a thing you ideally want to avoid. So you want to have those towards the end of the laptop, towards the backside, and you want them to be as close to each other as possible. You need the power components and the memory for each of them to be close to the CPU and GPU as well. So you have this cluster essentially of the key parts that you need to have close to each other, and you want that to be at the rear end of the laptop. And then that means there's only so much space you can use for the heatsink fins. That's why you'll see on more and more laptops as they become smaller and more compact that we add extra vents and other places as well, adding extra vents on the sides to then compensate for that reduced space we have here to actually dissipate the heat. So by adding extra vents on the side, you can then dissipate more heat and you can make the thermal module overall smaller.
It is so small. I mean, I can't wait to see
Mm.
what this is gonna be
And
inside
it's
because
super thin as well. I mean,
holy,
you can see like it almost disappears. It's almost two-dimensional.
yeah. So yeah, guys, this is the first look at a new device that will be announced next week during our CES 2021 announcement.
Hmm.
Unfortunately, that is all we can share with you right now, but
Yeah,
uh,
we're just teasing.
it's gonna be. I mean, I can't lie. I know what it is. I can't wait to for the world to see
Yep.
it because it's really cool.
You can see the nickel plating here as well on the CPU cold plate. So this one is going to have liquid metal as well.
Cool. Yeah. All right. So we've gone over pretty much all the different top beats as we'd call it when it comes to our cooling updates. Liquid metal becoming unanimous for every single device. We're gonna have the different profiles available for if you want to be able to full control for you. If you guys have any questions, please let us know and we can answer them about basically our cooling philosophies and what we're doing and how you can maximize the cooling for your device. We're happy to answer those questions. Lumi says it's a really cool. He's never seen such a cool heatsink. Get it? Cool.
All right. Yeah, it is definitely the smallest heatsink we've ever done for a gaming laptop. So for regular ultrabooks, there's even smaller ones, but for a gaming laptop, this is really impressively small and thin.
Yeah, it is a very tiny heatsink. And
And we can't talk about the CPU TDP and the GPU TGP and the total capacity, but it is pretty impressive how much heat you can dissipate with this tiny thermal module. It is really impressive, especially when you compare it to desktop PCs, where you have so much space and you have those really big heat sinks. And then if you think about, you can dissipate, like how much heat are you dissipating in a desktop PC? And how big are those heat sinks? And also graphics cards. And then you compare that to the amount of heat you're dissipating in a laptop and how tiny those heat sinks are. I think that's always really impressive. So yeah, I guess it's something about the scaling. I think to a certain level of power, you can still dissipate it with a really small and compact heatsink. But then once you want to dissipate more and more, you need exponentially more space and more volume to just remove all that heat.
okay, cool. Go looking at the 0 dB mode when the fans shut off, is it a gradual
Yep.
ramp up when they come back on, or is it just like I need to cool now and full blast?
Yeah, so the fans shut off, and then they always go to 100% and make sure they're actually there. No, of course we don't ramp them up to high speed. So yeah, they gradually go lower and lower and lower. We have a ramp down pattern and a ramp up pattern, and that 0 dB tech is only kicking in silent mode. So in silent mode, that's already where, the mode where you're willing to give up performance
Right.
to have really good acoustics. So that's what we thought it makes sense because yes, that's a very good point. Let's say right now the system is idle, the temperatures are low, so the fans turn off. It takes some time for the fans to spin up. And you need, ideally, it's really crazy how high CPU and GPU temperatures increase once the system is under load. So as soon as you load a benchmark or you start a game or you start editing a video or something, the CPU temperature spikes incredibly fast. It goes from maybe in idle, it's around 30 degrees. And
Hmm.
then as soon as you start giving it some work to do, it jumps to 80 degrees almost immediately. So
Yeah.
you want to be able to respond to that as fast as possible to then prevent the CPU from reaching, 100 degrees, where it then has to limit the performance.
Right.
So that would mean as soon as you notice that there's a tiny increase in the CPU temperature or GPU temperature, you then have to ramp up the speed ASAP. Like as soon as you're like, oh shit, full speed, ramp up the fans to full speed. So that would then mean that you probably hear the fan spinning up and going down and spinning up and going down. So we don't want to avoid that. So in silent mode, we are ramping up the fan slowly and we're ramping it down slowly. That means if you suddenly launch an application that is very demanding, the CPU temperature is going to go high and you're not going to get the full performance. But yeah, for silent mode, that I think makes perfect sense. And for people who want that super quiet operation, that's something I'm sure they can all accept.
Okay. So I think this is kind of a question just generally. Is intake from the bottom, exhaust out the side or the back? Where do we tend to see the intake and the exhaust?
Oh, intake, yeah. So that's a very good point. Essentially, people think that the intake is all from the bottom side of the laptop, and generally, a lot of people assume that just opening up the bottom of the laptop, making it fully transparent to airflow, so you just get all the air coming in. That's the best way to get the best possible airflow. That's kind of like in a desktop PC, you know? You can remove the side panel on your desktop PC and then you get better temperatures. But even on a desktop PC, there are scenarios where that's not actually the case. And you actually get better temperatures if you close the side panel, because then you're forcing the air to follow a certain path through the system.
Hmm.
If you design the airflow properly in a desktop PC, you do get better temperatures and acoustics if you close the side panel as opposed to having it open. And it's the same thing with laptops. On top of that, we also need to make sure we keep all the components cool, right? So one thing is we are guiding the airflow in the best possible way to have good temperatures for the CPU and the GPU and good airflow. But we also change the way the air travels through the system to cool all those other components. The SSD, the memory, the VRM components, and even the chassis itself. So on a lot of our laptops, and this is a common practice, but everybody does that on laptops, but nobody really talks about it, and it's not something that the general audience knows about. You always let the air, you simulate and you design the laptop in a way that the air flows over parts of the laptop that get hotter than other parts, and even design it so it flows over the inside of the chassis, so it cools down the surface temperature of, for example, the palm rest or other parts of the laptop that you want to have really low surface temperatures at. And we are pulling a lot of air through the keyboard because, especially, you know, when you're playing games, especially the WASD cluster on the left side, we want to keep that as quiet as possible. And it actually helps to cool your hand, like and dry sweat on your hand. If you know, get sweaty palms when you're really excited and playing a game, you get cool air streaming through between your fingers and then into the keyboard to cool the laptop. So to sum it up, a lot of air goes through the bottom side of the laptop and then flows over different components and then gets exhausted to the rear and left side and right side. And a lot of air, you'd be surprised how much actually, it's quite a big percentage, goes through the keyboard itself. So we have a lot of holes in the keyboard that we place based on where do we want the air to go through the keyboard to make sure this is where we get the lowest temperature on the keyboard.
Probably hot spots and yeah, strategically
Yeah,
placed. We might have
yeah, yeah.
answered this earlier. I can't recall. Are we doing anything to improve cooling of the VRM?
Yeah, so for some of the models, particularly the tough models, we have improved the thermal module, so it now cools the VRM. The thermal module cools the VRM directly now. So
Hmm.
yeah, that's an improvement. I think most people will probably, like, you won't notice it. It's not that, you know, you will feel a difference in how the system behaves. But it's definitely an improvement. It's definitely better to have active cooling for everything as much as possible.
Yeah, cool. All right, I think we've answered a good number of questions and gone into a lot of different components with what we're leveling up here with the cooling on our new devices. And as we mentioned, guys, next week is CES 2021. Like this is the week of announcements for so much technology, and we have here at Asus we have a lot to show off. So be sure to hit that follow button here on Twitch because we will have multiple live streams. I'm going to be doing a show here on Monday showing off something, and then we're going to have multiple streams on Tuesday. And of course, our YouTube channel is going to have a lot going on as well. So there's There's even more than just streams, and that's all I'll say. There's a lot of cool stuff on the horizon, and I'm really pumped to finally get to share this with you guys because everybody's been hard at work with all of this, and it's gonna be good. It's gonna be great. Sasha, any final thoughts before we close out the show?
It sounds like a really busy week for you.
Yeah,
uh,
yeah. I think I've got shows 5 work days in a row or something, which is at least one show
it's
per
a
day.
new milestone for you.
It for here at Asus, yes. I've done it. I've done worse in the past though.
Oh yeah, what's the most you've ever done? Like
Well, when I was a full-time
how
streamer and full-time commentator at the same time, I used to, I mean, we're talking like 40, 50 days in a row, without stopping. So
and like how many hours of being in front of the camera? Like how many, like 24 hours
the,
per day? How many of those hours were you in front of a camera?
the start of my career, probably 10 hours was the average, at least.
Wow.
Yeah, it was a grind. It was a grind.
Yeah, yeah. I mean, you have to be very careful about, what you say and what you do in front of camera. And doing that 10 hours per day for days on end.
When
Wow,
you're
that
plugged
sounds.
into, a video game and you're delivering a story, you're commentating, pro teams playing, there's nothing better than that. I love it. It's super fun. I miss doing it, but obviously I love what I'm doing here as well. So it's if you like the subject matter, it doesn't feel like
Mm,
work. I like talking about
yeah,
computers. I like talking about video games. It doesn't feel like work. So personally, I can't
yeah.
complain. But
So yeah, let's see if we can get back to more gameplay in the future. I would like to see that as well.
yeah, maybe I'll like put together some kind of fun little exhibition and tournament and commentate it or something that could be fun.
We could do something like where different people here internally, we face off against each other and we play a match, and you can comment on how
Oh,
awful we are.
yeah, might need a co-caster for that if I'm going to be put through that kind of torment. Um, but yeah, guys, I think all I have to say is be sure to check out all the CES content that's coming up next week. It's going to be a lot of cool stuff. I think we might have a couple giveaways that are going on next week during our streams.
Mm.
We'll have more details about that. So just be sure to check all the social media accounts. Thank you everyone that hung out and asked questions. We had a lot of really great questions today. So yeah,
Oh, we should definitely give a shout out to the Citadel, right? So on Steam, there's a really cool app called ROG Citadel. So an ROG app, an ROG game
did it
on
launch yet?
Steam.
I know they
It
announced
didn't
it.
launch now. It is announced, yeah. So you can
Yeah,
go to the Steam page and you can basically, as soon as it's available, it's going to be available in a couple of days. You can then download it and
it's
experience
free.
our products in there.
Yeah,
Yeah, it's free and it's pretty cool. There's a shooting range in there and some Easter eggs and everything. It's a really interesting little app.
I'm gonna be streaming it and showcasing it next week actually. So you'll get to check that out on Tuesday with a bunch of other cool stuff mixed into that. So a lot of fun stuff.
And you've unlocked all the Easter eggs, right? Have you?
I only know of one.
Oh, okay. There's more. There's
Okay,
more.
okay, I only know of one. But now I need to go look. Great. All right, guys, that's
Need to
going to do
complete
it.
everything.
Yeah, it's going to do it for us here on RG Pulse. We'll see you next time. GG's and take care.